It's math time with Heinz. It's math time with Heinz. Math time.
Hi everybody, welcome to lesson 3, but quickly we're going to finish up lesson 2 on page 8 here. So let's look at number 9. On the terminal side, that's the hypotenuse of an angle in standard position intersects the unit circle at this point. So first step is we've got to draw a picture. Negative 1/3, negative radical 8/3. So again, the hypotenuse goes through the origin, and I drop back to the x-axis. So there's my reference angle. And I know it's the point over negative 1/3 down negative radical 8/3. Now I could do the Pythagorean theorem, but they told me I'm living in a unit circle. So that gives me my hypotenuse of 1 already. So that was the key thing here. If my hypotenuse is 1, I already know what sine and cosine are. Sine is opposite over hypotenuse. Well, in this case, sine is just the vertical piece because it's over 1. So sine is negative radical 8/3. That's your y value. Your y value is sine. And my horizontal piece, my x value, is cosine. So the cosine of theta is the horizontal piece adjacent over hypotenuse. So I get negative 1/3. And that gives me the answer to this question. So when we're in a unit circle, we don't need to do the Pythagorean theorem all the time because we know the hypotenuse is 1. Sometimes you have to do it still, but I gave you all 3 sides here. I gave you x, y, and the hypotenuse. So let's jump into lesson 3. Let's jump into lesson 3 and skip the opening exercise because we just did that problem. So yesterday we went from 0 to 360. What if we go past that? What if I have a 390 degree angle? Well, we still start at this terminal side here. The initial ray here. We still start at the initial ray and we keep spinning. 90, 180, 270, 360, but I got to get to 390, which is right here. Because if I subtract 360 from that gives me an extra 30 degrees. So 30 degrees and 390 degrees are coterminal. Co meaning the same, and terminal means they land in the same place. So 390 degrees, we really use a 30 degree angle because 390 is just an extra spin around the unit circle. So when we encounter angles larger than 360 degrees, right, we just subtract away 360 to see where it's coterminal with, to see where it really lands. So let's practice drawing some of these angles. So if I have a 415 degree angle, that's too big. It's bigger than 360. So let's subtract away a spin to see what I'm left with. So I'm subtracting away a 360. I'm left with a 55 degree angle. So it's really the same thing as a 55 degree angle, except I have to spin around once. And a 55 degree angle is in quadrant 1. 840, too big. So what I'm going to do is I'm going to do 840 minus 360. Well, that's still too big, so I'm going to do another minus 360. I'm just going to keep spinning around the circle. So what this means is it's really 2 spins around the circle and lands at 120. It's 2 spins around the circle and lands at 120. So 120 degrees is in quadrant 2, right? So there's my triangle there. It's 2 spins around the circle, but it really lands in the same spot as 120 degrees. So it's a quadrant 2 angle. 1680. Well, I'm just going to sit here and keep subtracting away 360. 1, 2, 3, 4. So it's really 4 spins around the circle, and it really lands in the same spot as 240. So I'm not going to draw on those 4 spins because that's just crazy. But where's 240? Well, it's smaller than 270, so it's in quadrant 3. It's coterminal with this angle in quadrant 3. It lands in the same spot. It just spins around the circle a couple more times. And 2115, way too big. 2115. I'm going to do minus 360, I don't know, let's say 5 times. That was just a guess there. So I did 360, 5 times I took it away, and I landed at 315. I landed at a 315 degree angle. So it's really 5 spins around the circle, which I'm not going to do, but it lands in 315, which is a quadrant 4 angle, which we drop back down to the x-axis. And this is my reference angle. That's my reference angle. Okay, so when the angle measures are too big, we just subtract away 360 because that angle lands in the same spot. All right, so what if I have a negative angle measure? Well, normally here's 0 degrees and I spin up to 90, so it makes sense a negative angle measure spins clockwise. So negative angles spin clockwise. They spin clockwise around the circle. So what that tells me is I start at 0 degrees here, and I just spun negative 90 degrees, negative 180, negative 270. So that's how we deal with negative angle measures. So negative 30 degrees is we start at our positive x-axis, but I spin backwards 30 degrees. So it's really a quadrant 4 angle. It's really a quadrant 4 angle, negative 30 degrees. Because there's 0, I have to spin clockwise. Negative 225. Well, negative 90, negative 180. Well, that's negative 270, so it's really a quadrant 2 angle. A way that you can check this is you can add 360, because that's just a spin around the circle, right? Adding 360 or subtracting 360 is just a spin around the circle. So it's really a quadrant 2 angle that I'm working with here. Negative 300. Negative 300 degrees. All right, so negative 90, 180, 270. Well, negative, this is 0, but it's also negative 360 degrees, so negative 300 didn't make it there yet. So it's really a quadrant 1 angle. And finally, negative 120. Negative 120 spins right there, right? That's negative 90, that's negative 180. So negative 120 is really a quadrant 3 angle. Okay, so negative angle measures we just spin clockwise instead of our normal counterclockwise rotation. And finally, the last thing we've got to talk about is 0, 90, 180, and 270. What happens if I spin 0 degrees? I can't make a triangle. If I spin 90 degrees, how do I make a triangle? I always drop back down to the x-axis. Well, I can't drop down anywhere. So what we remember is our horizontal distance is cosine and our vertical distance is sine. So x is cosine, y is sine. This is the point 0, 1, cosine sine. Negative 1, 0, right? Negative 1, don't go up or down at all. And that's 0, negative 1 there. So using these 4 points on the unit circle, I can deal with 90 degrees, 180 degrees, 270, and 360, or their coterminal angles there. So when I say the sine of 90, I go to 90 degrees and I say, wait a minute, x or y? Sine is y, so the sine of 90 is 1. The cosine of 630, well, 630 is too big. 630 is too big for me, so it's really 270. So I really need to find the cosine of 270 here. Cosine is, it's alphabetical, x, y. Cosine is x, so it equals 0. 540 is too big. So I get 360 degrees. This is the cosine of 360. So 90, 180, 270, 360. Cosine is x, so this value equals the number 1. And finally, the sine of 360, well, we just said it's this point here. The sine of 360 is 0. Okay, so that's how we extend our trig functions. We have to remember cosine is horizontal. In the unit circle, cosine is the horizontal distance, and sine is the vertical distance. If you know this little triangle here, it's got a lot of information packed into it, and we'll discover more as the unit goes on. That's all I've got for this video, and I'll see you in class where we come up with a new way of how to measure angles. Such fun.